about all possible vSAN services. This is definitely not a dedicated vSAN class. The objective here is to, if you have no experience with vSAN, is to basically focus on the most important vSAN services you may need in your environment and give you something to start with. So the first vSAN service that we're going to talk about are the space efficiency features available. And you have two options to choose from. First one is compression only, and second one is deduplication and compression. So before looking at the two options in depth, I just want to know, are you guys all familiar with what deduplication is? Compression is quite simple concept, and everyone knows what compression is. What about deduplication? Are you guys all familiar with what deduplication is?
No, I've heard of compression, obviously, but...
Okay. So if you don't say anything, I will just assume that you are very familiar with deduplication. Okay. So deduplication. This is a storage concept. Okay. So compression basically tends to reduce both features. Have the same objective: reduce the amount of storage used when data is saved somewhere in a storage system. So compression will reduce the size by compression a file, or not necessarily a file. It can be done also at the block level. Compression is a concept that works like this. Let me just load the software for the tablet. I forgot to do that when I had the PSOD yesterday. Okay, so here's how deduplication works. So let's imagine that you have, let's say, small environment, okay, with something like maybe 100 VMs. Each VM is running Windows 10, okay? And Windows 10 with the same version of Office, same list of drivers, same everything. It's exactly the same VM, which initially was created using a template. So at the end of the day, you have exactly the same thing. To a certain point, the VMs will generate similar data, especially if you look at the log files and the updates that they will be getting and stuff like that. That's going to be exactly the same thing. So you're going to have, for instance, first VM that generates data A, B, C, and D. The second VM will also generate A, B, C, and D. Third VM will generate A, C, D. Fourth one will have A, B, and D, etc. Okay? If you're trying to save all this data into the same storage system, you can clearly see here that we have a lot of redundancy. It's basically the same piece of data which is written again and again, and that's going to result into a huge amount of storage used for nothing. Deduplication is actually an algorithm that's going to compare the data and write it only once. So for instance, here, we will only write A, B, C, and D. That's going to be written with additional metadata. that's going to be saved as well. So, for example, instead of consuming 1 gigabyte by 100, which is 100 gigabyte, we'll probably just write 1 gigabyte and then maybe write something like 10 gigabyte of metadata. That's 11 gigabyte written to the storage instead of 100 gigabyte. That metadata that's going to be written will serve as a journal for all sorts of modifications, because we may have this D changed here, but not in the other VMs. Maybe the C will be changed here. So we need to track all the changes. We need to add pointers. Whenever the VM, one of the VMs wants to access that data, it can know where the data is exactly saved. So that's what deduplication is, and that's how it works. It's a concept that used to exist for a while now, and it's widely used in many storage systems. There are some storage systems which have some really terrific deduplication algorithm that can result into something like a 9-to-1. Okay, the two features in vSAN work exactly the same as any other storage system. So the two algorithms used for deduplication and compression in vSAN are the well-known SHA-1 and LZ4. I just lost the... What's going on? Just 1 second, please. Okay. Let's do the basic things. Disconnect and reconnect. And it works. Okay. So for compression, we're going to use the LZ4. For deduplication, we use a well-known algorithm called SHA-1. Okay, that's actually what's implemented in vSAN. Just like any feature you have in the IT industry, if you want to enable any of these two features, you need to keep in mind that these are algorithms. And when we say algorithms, we need someone to take care of all the compute involved when running these algorithms. In a hyper-converged environment like VxRail, the resources needed for running deduplication and compression are taken straight from each one of the hosts, from the main CPU. You know, when you have a dedicated storage system on which you run deduplication, the storage system will take care of that. Deduplication is a quite heavy algorithm, because you can just imagine the amount of data that must be checked again and again each time there are changes and new data added, new data or data removed and stuff like that. So we need to keep an eye on the entire environment and entire data that we manipulate in our environment. So all of that requires heavy compute. So before enabling compression or deduplication and compression in your vSAN environment, I would say that you need to take this in consideration during the sizing phase of your environment. As you know, every environment goes through a sizing phase before getting deployed, sold to the customer, etc. During the sizing, we need to determine what is the requirement, and what kind of design is going to work for the customer. How many nodes, what type of nodes, etc., etc. Okay, the amount of memory, CPUs that are going to be used, and if you are planning to enable deduplication and compression, you actually need to take that into consideration. So you must add that to your sizing phase, so you can allocate additional compute resources that are going to be used for these two options. Okay. Something else that you need to keep in mind when you are managing a vSAN environment, there are other options that can help to reduce storage usage. We talked about that yesterday, RAID 5 and RAID 6. Okay, these are two RAID options that can guarantee a reduction of the storage usage, regardless of the data you are using in your environment. So if the different workloads you are running can work just fine using RAID 5 and RAID 6, that's a good option to consider. As a reminder, yesterday we said that for an object of 100 gigabytes, if you use RAID 1 with an FTT of 1, the object will consume 200 gigabytes because we're going to have a mirrored copies of the same object. If you use RAID 5 for the same FTT, the object will consume only 133 gigabytes. And for an FTT of 2 using RAID 6, the object will consume only 150 gigabytes. You're going to have the same FTT as RAID 1 with an FTT of 2, which would consume 300 gigabytes, so double that number. But again, there are advantages and disadvantages of using RAID erasure coding, which means RAID 5 and RAID 6. Some workloads do not work really good with this kind of RAID. Okay, so the two features you are looking at here, compression only, deduplication and compression. First of all, they require all flash hardware. These are not available in hybrid environments. They need to be, you need a licensed environment with the advanced license, at least. And the two options or the two features will be applied when data is destaged from the cache to the capacity tier. Okay, yesterday we talked about how data is read and written in vSAN. And we talked about the destage. The data will hit the cache, then move from the cache to the capacity. As you know now, so if you have multiple VMs right into the cache, so we're going to have a lot of data hitting the cache first. And then all of that will be destaged to the capacity tier. At this moment, we will apply compression and deduplication. When it's compression only, that's going to be applied to each block of 4 kilobytes. Okay, we're going to apply compression. If the result is actually less than 2 kilobytes, which means the block will be reduced to less than 50%, the block will be written compressed. If the result is higher than 2 kilobytes, then the block will be written without compression. We'll just keep it as it is. Okay? So compression is applied to each one of the blocks. Compression works best for workloads that generate data which is easy to compress, like some configuration files or non-compressed files in a raw format or some text files and stuff like that. If in your environment you have mixed workloads, compression can be considered. If you, however, have an environment that generates, some sort of data which is natively compressed, like if you are using for video creation some high compression algorithms, H265 or something like that, that data cannot be compressed. It's not good for compression. Now, deduplication and compression. There's no option to enable deduplication only. So if you enable deduplication and compression, this is how it works. So first of all, we will deduplicate the data. Okay. Deduplication in vSAN will look at the data only at the level of the disk group. Okay. This is a disk group. Okay. We will only compare the data within each one of the disk groups. And this means that deduplication will be applied to all the data that we find in our cache, which means that if we have some data which is similar across multiple disk groups, we're not going to compare that. Okay? The deduplication is limited to each one of the disk groups. So first of all, we will deduplicate the data. So the algorithm will look for redundant data and then write it only once. And then when the data is deduplicated, we will apply compression to it before it gets written to the capacity tier. Okay, so this is how the two options work in vSAN. As a best practice, it's better to enable any of the two the first beginning. Once the cluster is deployed, if you need any of the two to be enabled, you should do that at that moment. Why would you need to do that? Well, simply because when you enable any of these two options, we're gonna need to format each one of the disks in your vSAN data store to prepare them for compression or deduplication and compression. And when you have some workloads already deployed, when you have VMs already deployed in your environment, this means that we have data written everywhere. So if we want to format these disks, the data needs to be evacuated. And that's a very long process that can take a lot of time for evacuating the data, then formatting the disk, then migrating the data again, and so on. This needs to be repeated for each one of the hosts, which is going to consume a lot of time and is going to also impact the performance of your overall cluster. Hence, the best practice is to enable this in the first beginning. So if you consider this during the sizing, you will simply enable it at the moment you deploy the cluster. Okay, so a couple of additional notes regarding compression only and deduplication only. When you enable compression only and you experience a capacity disk failure, we're not talking about cache here. In vSAN, if you lose the cache, the disk group is gone. Okay? There is no disk group without cache. So losing the cache means the disk group is gone. And all the data within the disk group must be rebuilt somewhere else. So when you have compression only, this is important to remember. When you have compression only, and there is a failure in one of the capacity drives. In this case, that disk will need to be replaced. It's not going to affect any of the other disks or the disk group. Okay? If you have deduplication enabled, that's another story. With deduplication enabled, remember from the explanation, deduplication will create a journal, metadata, that's going to be saved into the same storage. So you can track the data changes and where the data is located and add pointers and stuff like that. So the metadata, when you have deduplication enabled, will be distributed across the disks within the same disk group. This means that if one of the capacity drives fails in an environment where deduplication is enabled, you're going to break the metadata within the disk group. In other terms, losing one capacity drive, when deduplication is enabled, means the entire disk group is gone. It's equivalent to losing a cache. This is one thing that you need to consider before enabling deduplication. Okay. Here you can see the saving, if it's moderate or big saving. Nothing is really guaranteed. When you enable any of the two options, it doesn't necessarily mean that the results will be guaranteed. It's actually, it all depends on what kind of data you have in your environment. This is a table taken straight from a VMware blog, official blog, that shows you the type of workload and what's actually recommended to be enabled. And as you can clearly see, the only type of workload where deduplication is recommended is VDI workloads with full clones. If you're not familiar with VDI and what full clone means, well, as the name indicates, this is actually an environment where all the VMs are almost the same. Okay, there is a good practice if you want to get some good results with deduplication. Not necessarily not exclusively in vSAN, but in any storage system. You can use templates to build your VMs. So at the end of the day, all the VMs will look like the same. So when you have similar data, you have an environment which is a good candidate for deduplication. Okay, so here you can clearly see that for everything else, like databases, mixed workloads, anything else, compression is the best option. So how do we enable any of the two options? So you select the cluster, then configure tab, then vSAN services, and from there, as you can see, by default, it's set to none. You have the option to enable compression or deduplication and compression. Then you click on apply to start the reformatting. There is an option here, okay, called allow reduced redundancy. What does it do? So this is an option available for customers with VMs already deployed in the environment. So let's imagine this environment. We have 4 nodes, okay? We have a VM with data distributed like this. So it's read one with an FTTF1. The VM has a component here, and the witness here, okay? We just decided to enable deduplication and compression. As explained before, this will require reformatting the disks. So what you're going to need to do is, when we want to reformat all the disks of the first host, we need to migrate the data. So for example, this component here, we need to be migrated to this host. Okay? So if you have terabytes of data that need to be migrated, it may take a lot of time. Okay? The migration of the data will go through the same vSAN network. It's going to traverse the same vSAN network. If that network is busy reading and writing, it can take a lot of time. If you select this option, allow reduced redundancy, this can accelerate the enablement of deduplication and compression by simply not migrating some of the data. How does it work? So let's look at this example. This VM has redundant components into the other two hosts. So if the VM is running here, okay, the VM can definitely be served from this component. Because if we lose this one, we're going to have quorum. we're going to have more than 50%, so it's not going really to affect the VM. So if you select this option, you're just asking vSAN to put the VM at risk, okay, by ignoring this component, not migrating it during that period of time of reformatting the disks. As a result, you will quickly enable deduplication or compression, or both, by tolerating period of time where the VM is put at risk with no redundancy. Because the problem that may happen here is that if you experience a failure during this operation of enablement, if, for example, the disk that contains this component fails, the VM will become inaccessible. Okay, so if you don't want to take this risk, you simply just enable any of the two options in the first beginning, before even having any of your VMs deployed in the environment. This is typically for people with VMs already deployed. And it's not mandatory, it's optional. Okay. And one last note, of course, the system is intelligent enough to detect that in this particular example, yesterday we didn't talk about RAID 0, but it does exist in vSAN. Okay, you can definitely configure RAID 0. So no redundancy at all. I can have, for example, a VM running here, and it does have only one component, okay, placed here. If you are wondering why would we have RAID 0, well, if you have a testing and development VM, why would you waste some storage for it? If it's just for testing, you can just deploy it using RAID 0 without having redundant data or whatsoever. Or when you have a VM that runs an application that replicates itself, we have replication at the application level. Why would you need to replicate the data using vSAN? That's going to consume just more storage. So these are examples of use cases of RAID 0. In this case, if you select allow reduced redundancy, vSAN is intelligent enough to know that redundant for this VM, this component will need to be migrated, maybe here. But if you have another VM with component witness, this one here will not be migrated because it knows that it has a redundant copy somewhere. When you enable any of the two options, you can see how much storage you are saving by looking at the capacity from the monitor view. So select the cluster monitor, then scroll down to vSAN, click on capacity. And here it's not really visible in this slide, but just below here you can see compression saving, for example. Here we saved 144 gigabyte with a ratio of 1.2x. Okay, and you can also see the details. Here you can see the compression overhead. This is a huge number. Again, most of the screenshots are not taken from production environments, so this is too much. But you can definitely see the compression overhead, the deduplication overhead. All the details can be visible from here.